This conference will now be recorded.
All right, so thank you very much. So how many people know what tally tables are? Okay, yeah, you guys should.
Oh, sorry.
Okay. All right, so what we're going to talk about are what tally tables are and how we can make use of them, how we can make them, build them and make use of them.
Can you tell us the history of why they're called tally tables?
You know, I can't. I really don't. I don't know. I was trying to figure that out before, and the only thing I can think of is that to tally something is an old term used to count something. So if you wanted to, tally your wages for the day, to count it, or, tally your inventory, that's count it. And so a tally table is basically just a table of numbers.
And that's how I was just gonna, I wondered if you were gonna tell us that. The tally table is actually an alternative name. They used to be called the numbers table.
Okay, that's true. That is true. It used to be called numbers table. So, so you're probably wondering who I am. All right. Well, I am a BI engineer at the Church of Jesus Christ of Latter-day Saints. I get to work on not SQL Server, unfortunately. That's a whole nother group. I'm been banished to the Oracle realm and Tableau. I used to be the chapter leader for the Indianapolis past chapter, and that's why I really push attendance at past chapters. It's a great way to expand yourself. I've also spoken at SQL Saturday sessions all over the country. In fact, my very first one that I spoke at was here in 2012. So thanks to Pat for getting me started on that. I did get a Bachelor of Science in Computer Science at Ball State University. Anybody ever heard of it? Okay, Dave Letterman, that's where he went to school? Okay. Yeah, so that's about what it's worth. And yeah, yeah, exactly. And then I went to the University of Phoenix online, got a Master in Computer Information Systems. That was because my company was willing to pay for it at the time, so I did that. But I was a glutton for punishment when I got into healthcare. I went back to Indiana University and got a degree in health informatics, and I really enjoyed that. But all in all, I've been doing this for over 30 years. I'm going to say how much over, but it's been for a while. So today, we're going to talk about what tally tables are, what the purposes and uses are, and how to create them. We're also going to talk about how you can use them to find missing data, how you can use it to break strings, how you can generate data, and in general, how you can use them to replace loops and cursors. Then we'll have a few more closing thoughts. I thought it was pretty interesting. Went back and looked at a lot of curriculums for programming classes that universities are cranking out. And it boils down to about 5 basic concepts for programming languages. Of course, the first one you have is program structure. And it's the overall form of the program, how you're supposed to, make the main structure and your main function, whatever it is, whatever language you're using, and the interrelationships between those individual components. And then next, you have your variable declarations. And these are always helpful, your naming and the data types. And then third are looping structures, including conditional looping structures. And then you have control structures such as your if statements and your case statements and for logic flows and branches, and your syntax rules and language rules. But there is generally nothing established about set-based operations. These are all very procedurally oriented. How many people would consider themselves to be procedural programmers? Anybody know what procedural means? Okay, procedural is basically like computer programming and C, C#, Java, .NET, like VB.NET, C#, all that. That's procedural programming. So what is the big deal about procedural versus set-based? It seems to be quite a battle that rages on about it. So let's talk about that. So procedural programming, data is usually very abstract. The structure of the organization of the data is not as important as the structure of the program itself. And usually they're separated by several layers of abstraction. One of C# developer I worked with, he was very pleased because he had so many layers of abstraction in his code, and that was great for his code reusability. But then when he went and developed T-SQL modules, store procedures, he incorporated the same kind of logic in that. And he wondered why things did not perform well. And that was because in compiled languages, those layers of abstraction are smushed down. And whereas in T-SQL, it's interpretive. So you get what you get. Procedural programming is more concerned with what you're doing and how to do it. It's known as an imperative language because you are dictating to this computer how to do things. And that's done, like step by step. You use statements and loops and object manipulation and pointers and all those kind of cool things. You identify the different logic paths depending upon the data attributes. And it's generally performing record by record processing. It provides total control though. You know exactly what it's going to do. You control every aspect of it. And the execution method will be consistent each and every time. It'll always do the same thing the same way. Or at least it should, as long as you don't have any bugs. Contrary to that, set-based programming, it describes more of what should be done. So it's known as a declarative language. It indicates the operations that you want to have performed and also the conditions that you want it to perform in. You'd say, I want to select data from this table where these conditions exist. The thing is that you allow the engine to determine the best way to go about executing your query. It takes into consideration the data structure, how the data is organized, the volume of the data that you have. Statistics, wow, easy for me to say. Statistics from previous runs, so it can improve upon itself. It frees the developer from actually worrying about the mechanical and the specific details of how to execute your queries. And it allows for changing conditions without altering the query. If all of a sudden, the DBA decides they're going to add some more cores to the server or additional memory, well, that could affect how the query gets executed the next time. But you don't have to do anything about it. It'll make the changes for you. And relational database management systems are really optimized to select or manipulate record sets as a whole. And this is especially true for SQL Server, but there's a price for that, and that it won't perform procedural operations nearly as efficiently. So, question is then, what are tally tables? No, not Teletubbies. Tally tables. You were expecting that, weren't you, Ben? All right. So tally tables, it's a numerical sequence table. And it allows you to perform set-based sequence logic. So through that, you can replace loops and improve performance overall. Jeff Moden, anybody ever heard of him? No one else? Okay. Jeff Moden, he coined a term called RBAR, a row by agonizing row. And you want to do everything you can to avoid RBAR functions and procedures. So you want to avoid processing each row at a time. You want to touch it as little as possible. And according to him, it's the most common performance killer in T-SQL. Also, tally tables help promote set-based operations. Again, because we're removing loops and cursors from the system. So let's take a look at how it works. So let's say that I have some string values. And as you can see, I got really imaginative in my examples. So we're going to take this along with our tally table. As you can see, it is literally just a sequence of numbers. And with that, we're going to arrive at pretty much a Cartesian product between these two. So you can see the string 1 gets repeated 10 times, string 2 gets repeated 10 times, etc. Now, this by itself is worthless. However, if we want to say, let's go a little bit step further. Let's say I want to limit my strings to my numbers to the length of the string. Now I get a little bit more interesting, because 1 appears 3 times because there are 3 letters in the word. Same with 2. 3 has 5 rows because there are 5 letters in there. Okay, so that in itself is not as interesting, but let's say I want to highlight each letter in the word. And because of this, I know that for this number 1, I highlight the first one. This number 2, I highlight the second. This number 3, I highlight the third, etc. And most times, to do this, you would loop through the strings 1 character at a time for each character string. But then we did this without a loop. So let's take a look how we did that. Okay, so we have here, again, as we saw on the screen, we have our words right here, 1 through 5. We have our tally table. This is just a small one for this example purpose. So let's go ahead and display this. So we have our 1 through 5. And then we have our tally table here, 1 through 10. And then the first one, we were doing a cross join with them. So let's do that. And we have the 1 appearing 10 times, 2 appearing 10 times, etc. Now let's limit it to where we want n to be the number of characters in the string. So we put this little where clause in there, where we want n to be less than or equal to the string length. And then that's how we get with 3 for 1, 3 for 2, 5 for 3, etc. Everybody with me? Now the part where we want to highlight each character. Now we can use the tally table to essentially loop, and I put that in quotes, through the strings and highlight each of the letters. Boom, we do that. Now what we're doing here is that we're saying the same thing where we have our string values, we have our number table, and the same thing here where we're specifying the string length to be no more than the number to be no higher than the length of the string. And then we just do a case statement here where, of course, if I'm the first one, I have nothing to the left of the string, and I go ahead and highlight the first one, and then in my highlight, and then put the rest of the string on there. So it's fairly simple and straightforward. But this normally would have been done in a loop. Questions on this? Yes. I can do what? Yes. You can use the tally table anywhere. I'm getting to actually how we build them next. Okay. So for right now, this is just a literal values list. Okay. I haven't created a table. Any other questions? All right. Let's talk about then how we actually build it. So I'm going to get rid of that. Here is a function, a table value function that will create a set of numbers from 1 through 100,000. And I'm sorry, 100 million. for 100 million. And we can actually make it bigger if necessary. But for most practical purposes, this is more than enough. So what we're doing is that this is a table value function. So we're going to return a table. And I put with skip up binding because that way it's fixed at that point. We're going to take advantage of cross joins. And so we're going to take our values of 1 through 10. Now, those number ones, that could have been anything. I could have put, George, Mary, Larry, whatever. The value itself was unimportant. It's the fact that there are 10 values or 10 rows. And then I'm going to take that and cross join it, this exponent 1 to exponent 1. So basically, I'm going to get 100 records. It's 10 times 10. Because 10 records cross-joined with 10 records gives you 100. And then for my exponent 4, I'm going to take the exponent 2, cross-join the exponent 2. That's 10,000 records, basically 100 times 100. And then for exponent 8, it's going to be exponent 4, cross with exponent 4. And that's 10,000 times 10,000 gives you 100 million. Now, of course, if you did exponent 16 of 8 times 8, that'd be really insane. I can see where maybe you would want to go up to exponent 8, or exponent 10. Can anybody tell me how you could do an exponent 10 from there? You take the exponent 8, you cross join it with exponent 2. 8 plus 2 is 10. So it's a cool trick that we're making use of. And because we're doing it with very small values, it's fast. It's insanely fast. Now, we're going to do another thing too. Again, the value itself was not so important because we're going to get our value from a row number function. And we're going to say order by select null because we don't care what order it is because they're all the same value. And then I've optionally included, or not optionally, I included in here a row count so you can set a max to it. So I can say if I want only, say, 8,000 because I'm going to be dealing with varchar strings, then I would put 8,000 in that, and this will give me the top values for that. What's interesting, yes?
Do you have a practical number you use in your experience that is like, hey, you should have a number table this big?
I've never really exceeded much higher than, I think it was like 13,000 records or something was about the most I've ever used. And I'll show an example of that here in a minute. But yeah, I haven't seen where you need to get it insanely large. But what I did find interesting here is that let's say that I put my top value of 8,000. This exponent 8 actually gets ignored. So it doesn't even calculate that. So when it does that top on there, then it does it for the 10,000, just gives you the top 8,000, there you go. So, you can adjust this selection as needed if you really need to go bigger, but realistically, I haven't found a need for it. The other thing that's really cool too is that because it's a table value function, it all happens in memory. Now, we could create a table itself, put it out on the with all the other tables, and then every time we query it, where is it going to go to get the data? From disk. Whereas this is now in memory. So let's go ahead and let's build that one, because we're going to make use of it. And I've also got a couple of variations here as well. Like here's one, it's identical to it, but I want to start with level 0. And you're probably wondering why. I mean, numbers table is 1 through whatever. Well, this one I want to be 0 through some number. And because there are some really cool places where we can use that, and I'll show you one here in a minute. So this is going to be our tally 0. And I haven't personally found a need for this one, but I created it anyway just because I was in the mood to do it. This one allows you to create a function to do an offset. Let's say I don't want to start with number 1. I'm going to start with 100 or whatever it is that my situation needs. So I can tell it that I want to say a maximum number and my offset. So I can say, give me a maximum of 10,000, but offset it starting at 1,001 or whatever. So this will do that for me. And again, this is all in one set-based query. Now, for those of you who really need to have a table, okay, yes, we're talking about tally tables. So we can create a table for this. So here's some code. If you really want to do it, you can create a tally table and populate it. We're using the same methodology to populate it. And then we're going to put some grants on it for select and references on here so that nobody can really muck with it. So let's go ahead and do that. Why is this one taking longer, you wonder? Yeah. Because we're actually populating the table. And it's got to write the data out. Exactly. Okay, and this should have completed by now. I don't know why it's... I'm sorry? No, actually, it's just a function, all right? And it'll actually then populate, or the function will populate at the time when you call it. Okay. Right. Okay, I'm going to stop this one. I don't need it. Okay, let's talk about our first one here. Now here's an example. I want to see how many people have a birthday in each month, but you don't want to skip any months. Because, for whatever group of people you have, let's say the people here in this room, there's going to be a month that could be skipped. But we want to know that. Now normally, when we would do to do this, first of all, let's create our table here. Let's put some values in it. Oh, yeah. You like them ducks, huh? I wonder why. Okay. Oh, wouldn't you know this? My query still hasn't canceled previously. Come on. Probably shouldn't have executed it because we're not going to use it. All right, there we go. Now let's go ahead and create our data table. Now, normally when we would want to determine, what months there are for birthdays, we would run this query. And this will tell us that for each of these months, how many people have birthdays. But you notice we have a gap here. We're missing June, July, and August. So let's take a look how we can do that. Let's use our tally table, or excuse me, our tally function. How's that? Our tally table function. How's that? Tally table function. There we go. I still got table in there. Okay. So we're going to then determine that with our tally table, and then we're going to do a left join to the persons list because not everybody is going to be represented in there. And we're going to use 12 for our upper range. Why would we use 12? Yep, that's right, the number of months. So let's go ahead and execute that. And as you can see, we now have June, July, and August represented with a 0 count. Now, I'm sure this is going to really, help you out in your production code right away, huh? Okay. Again, these are simple examples. But here's another one. Let's say you're working in your data warehouse and you want to have your date table, your date dimension set up. Well, we don't have to loop through all the records. We can just say here I want for the everything in the third millennium. For all the dates, days, months, I could have added quarters and stuff like that. I just didn't do it. So we go and execute that, and boom. Now, of course, it's got to finish up a little bit more, but as you can see here, we started getting here are the dates, here are the day, the month, the year, and it finished, and it took what, 8 seconds to generate 365,242 rows. Yeah. Do that with a loop. I dare you. Okay. Now I've got another one. Now, I know in SQL Server 2016, string split is available now as a native function. Yay, took long enough. So let's see what we can do. I'm going to take advantage of these tally tables to show you how we can do this with strings. So yes, there is an Irish joke here, and I'll let you guys read that later. So let's say I want to break this up into strings of 50 characters each. So I'm going to put here my max string length, and I use my tally table, and here I'm going to use tally 0, the function tally 0. And I execute that, and boom. I broke it up, and each string length is no more than 50 characters. And I identify my string ID and my segment number. Okay, so let's say if we take those strings, and now most user-defined functions, scalar functions, they do a really poor job at handling these. But there are a lot of people that do it with the loops, and so here's an example of how to do it with a loop. Now, I'm not going to run through this. One thing I did find interesting is I wanted to show, according to the execution plans, the difference between doing the user-defined function, and yeah, it was pretty bad, and showing that against the one with the tally table function. I discovered that when you use a tally table function, it becomes part of your execution plan. Whereas if you use a user-defined function, it's invisible to it. It doesn't show it in your execution plan. It'll just show, boom, there it is. And it looks very simple, straightforward. And you're like, well, that's the cheapest cost right there. What's the problem? But it doesn't show you what goes on behind the scenes. So I didn't want to get into that because I was really shocked with that one. Yes. What is it? What is it?
There it is.
Oh, there it is. Yeah, I like that. So let's take a look at this, how we would do a string split with the tally table function. So here is a function. If you really want, I can go into explaining how it works, but it's one query, uses a CTE for the starting position, a CTE for the segment length, and then here is our function right here. We execute that. And this also allows for you to specify what the delimiter is. Notice we used a tally table function here with the upper limit of 8,000. So let me go ahead and create this one too. Okay. So if we were to use the procedural function, it works. It's kind of hard to tell because the elapsed time is relatively small because this is a small set of text. But then we use the tally table based function. Boom, there it is. Now,
Play it. She's got it. She's got it.
Thank you. Okay. So any questions on string splits? how we use tally tables for that. Because let me actually go back, clarify here on the string split function, that we're using this tally table function here to identify each of the delimiters. So we're using this substring here to identify where that delimiter exists. And when that tally table tells us for each segment for those delimited areas. And then this CTE just tells us what the segment links are, so we can do our appropriate substring calculation here. Any questions? Anybody lost? Okay. This code will be available. I'll show you where, so you can download it and take a look at it. I know this is kind of one of those things that you have to sleep on for a while for it to sink in. Let's take a look at another one. Now, how many people have create test data? Right? Yeah, everybody creates test data. So let's create a table here that we're going to do test data in. And most people will do something like this. I'm going to insert 1,000 records into this table, and I'm going to use the go functionality. What does the go do? Yeah, it loops it. So a lot of people think, well, guess what? I'm not doing a loop. I can do this without a loop. And notice, beginning of execution loop. And one row affected, one row affected, one row affected. It's doing an insert, single insert for every one of them. However, if I were to do this with a tally method, so here is, I'm going to truncate the table and insert the data. I'm using a tally because I want 1,000 records. So I'm using that as my loop. And boom. And it does this as a single insert. All 1,000 rows as a single insert. So it kind of goes to show how to take advantage of set-based functionality. Now, how many people in their organization uses prime numbers? Yeah, I didn't think so. But I like the idea of it because it was kind of a cool way to show the difference between a procedural method and a set-based method. So if you go out and Google, you can find all sorts of examples of how to generate prime numbers. And every one of them that I found involved a procedural approach. And it was because we have to loop through it and we have to compare the numbers to what was done previously, et cetera. And so you can see on here that, here's our while loop. I'm going to generate prime numbers all the way up to 1,000. And now we select numbers, and here's this. I took this code from, I think it was it's either a Java or a C# example. And I translated it into T-SQL. And it actually works well for a loop, but you can see it's pretty complex. So let's go ahead and run this. Boom, 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 boom. And let's do our select. And it finishes there and got 169 rows. Now this is a pretty small example, so we don't see much in the way of latency here. But let's look at a set-based method. Wow, a lot less code. A lot simpler. Here we are using our tally table function for up to 1,000. And then we can do our comparison between our numbers here. So here I'm doing it from our prime numbers here, and then where not exists, and then I'm doing a subquery, again of 1,000, so we can compare the numbers between the two. And I put some comments in there to how that's done. I really truly don't understand the whole process of it. All I know is that prime numbers are divisible only by itself and one. That's the essence of a prime number. But when we go to execute that, boom. And so we get the 169 rows and everything's all hunky-dory. Any questions? Anybody going to go out and generate prime numbers just for the fun of it? When I was doing some research, I thought it was kind of interesting. I also tripped up on somebody who was calculating pi. And there's a whole history about how people are, calculating numbers, all the digits of pi, because it's never any number. And before computers and calculators and everything, I was pretty amazed at how far some people got with that, because it's a continuous math operation. And then, of course, when we got the advent of supercomputers, it went up. And I think it was just a few years ago, it went up even further. They're now like in the millions of digits to pi. Why did you want to do that? I don't know. I guess it's because it's there. Yes. And we can use a tally table to do that. Yes. Okay. So let me get back to here. Yes.
How do you step into the tally table paradigm? You say, okay, I want to do this set based as opposed to procedural based.
Yep.
Anytime you do procedural, then let them do it. What are some steps? What's a template you use to say, how am I going to get my query so I'm doing all tally table as opposed to this?
Okay. So how do I develop a template for converting loops into set-based using a tally table?
Yeah.
Good question. It seems that every situation has been different. In all of these examples, you saw how they were implemented differently. I don't think there is a pat answer for that, unless Pat has an answer for that. Yes. And that's the biggest paradigm shift right there, is the thinking in terms of not what I'm going to do for every row or how I'm going to iterate through this, but thinking of how can I do this as a set at one time. So, when I did the prime number example, that was kind of cool for me to, think about how could I do this in a set-based manner. I didn't find any examples like that in Google at all. So I created it. So, you what? What's that?
I did have one. The most common place that I always see this, the most common place that I've used a tally or a tally system like this is when you're trying to find that hole, that zero that you get at the beginning of months. Because in code or anything, all you can do is loop through everything to get the zero to show up. Well, with a function and a join, then you can take that out and it's always faster. So 9 times out of 10, whenever somebody comes to me and I switch to a tally table or something else like that, it's because of performance.
Yeah.
Someone has written a query that is a loop and it takes too long. And you can't find a good way to do it with a join. The next statement becomes cross-apply, and then you're like, okay, hold on, don't do a cross-apply because they're dangerous. And then you say, okay, now how can we use that as a tally table? And that's where it comes. And that's every time that I use it.
Yep. Exactly. Now, I do use cross-apply for tally tables, for the tally table function.
The function, right?
Yes.
That's what I mean. Well, what I mean is somebody comes to me and says, well, can we cut a cross-apply to get the zero out of there or something like that? And then they run into problems.
Yeah.
They can't figure out how to do it until they get a table.
Exactly.
They try to cross it back to themselves.
Yeah.
They'll join it back to themselves.
I'll tell you another use case that I've had. I didn't present on here. Working on a project, it's funny, we were talking about data lakes earlier. We were pulling data from multiple systems into a data lake. And they wanted a way to be able to validate that we were getting the same data in the lake as we were in the source system. So generally, it'd be real easy to use a hash function to generate a key for that data and compare it. But the problem is that I'm comparing what I have in the data lake, which was in Postgres, to Oracle, to SQL Server, to DB2. Well, the hash functions are implemented differently in every one of those, so we couldn't compare them. So then the other thought was, well, what if I take everything, convert it to a text string, It's in the row because most of it was text anyway. And then, not that it would be a perfect evaluation, but let's take the ASCII value of every character in there and then add them together. So it'd be kind of like a checksum in that sense. And so to implement that, I implemented it in DB2, in SQL Server, and in Postgres. And the nice thing was that, the other one was Oracle. The only problem I had with the tally function, the tally table function, was in Postgres. And then I come to find out that they have a function built in for it, so it wasn't needed anyway. So it was funny because everything performed wonderfully in all the other systems except for Postgres. And then, they have a built-in function, so I used it and everything was good. And it worked because then I was able to export from each of the systems. Here's the main key. Here is the calculated value for all the ASCII values of it, added them up, and I could compare those. Now, it didn't guarantee that things weren't out of order or anything of that nature, but it was a rough sanity check. That was good. Anything else? All right, cool. Let's take a look back at this. Okay, so here's some caveats for you. Set-based processing does not mean all in one query, because it is very easy to hide loops in a single query. For example, poor user-defined functions, recursive CTEs. Those are loops that are hidden. You also saw that one example with the inserting data into a table using a go statement. Yeah, we had one query, but it was a loop. It does not necessarily mean something without a loop, because there are times where you can implement loops to improve performance and to encourage set-based operations. I've actually had situations where I wanted to, I was doing some logic processing, and it was kind of like think of it like an algebraic where you like, I want this and this, or in parentheses, and this or this, etc. And to do that most effectively, I looped through the levels of the logic and used set-based for each level and for all data. So if I had my deepest query or deepest statement was 5 levels deep, that's all I looped was 5 times. Everything else was set-based. It can mean something that has a loop, so just like I mentioned, where I use multiple sets to process that. It does mean touching each row minimally. So you want to touch each row as little as possible for it to be set-based. And it does require a paradigm shift in thinking. So it's like, what he said, if you get your mind switched to thinking in terms of sets, then you can think in terms of how do I apply tally table functions to replace the loops? How can I do this in a more efficient way so that it's set-based? For example, like I mentioned, other loops and cursors, recursion is one of them. A recursive CTE calls itself as a hidden loop. Now, I have used recursive CTEs. I used to love them until I found out what they really do to our system. And what I did then was I replaced it with the loop that I mentioned, where I take each level. I determine how many levels there are, and I loop through those number of levels and perform each level from the bottom up. It can kill performance about 3 times or more with the resources of a single simple while loop. And this is from Jeff Moden, made that observation. Most recursive CTEs can be rewritten as a set-based manner using a simple while loop. So a recursive CTE loops through each level of recursion, and each loop requires the results of the previous loop. Performing the loop explicitly saves resources to run faster. Instead of having the system try and figure it out generically, you just do it explicitly, and it'll run a whole lot faster. That way, 3 levels of recursion can be processed in only 3 loops, the 3 iterations of the loop. There are explicit cursors. How many people have used cursors? Oh, come on. Now, I will say, there are times and places for cursors. Cursors in themselves are not evil. It's how they're usually misimplemented is what makes them evil.
If you have the right accent, cursors
Okay.
Still doesn't make it equal.
No.
Just saying.
So an explicit cursor, the query places data into an internal structure and fetches one record at a time. Now, here's where people trip up the most, though, is that they leave it with the default settings. Now, in SQL Server, it allows for forward and backward traversing of the data as well as data updates. But 99.9% of the time, you don't need that. So you do instead a fast forward implementation. So you use the local fast forward and read-only options, and it'll perform so much faster. There are also internal loops within SQL Server. There are hidden but very high-speed looping that occurs behind the scenes when you're processing your code. For example, when you're using window functions. A simple select statement even iterizes through the rows. But the optimizer knows how to handle these in the best way possible. I already mentioned the windowing functions. And, because windowing functions, especially if you use things like lag and lead and those, they're very, very fast, very efficient, and I love to use them. But they are an internal type of looping through the result sets, but extremely efficient. So the purposes and uses of tally tables. Everyone got a better handle on it, how we can use them? And then we talked about how to create them. I highly, highly recommend the inline table value function as opposed to the fixed table. I've had some people that they say, well, if it's not in the table, then we can't use it. We can't do, they're all worried about performance and the things that they gripe about, especially like CTEs. They say, oh, well, that'll kill performance. Well, it's just the knee-jerk reaction a lot of people have because of poor implementations. Again, like with the cursors, they're not evil in themselves. They've been poorly implemented most of the time. We can use the tally table function to find missing data, perform string splits, generate data, and again, replace loops and cursors of many types. So that has many, many benefits over loops and cursors. For one, it's set-based. It improves your performance. It simplifies the amount of code that you need. You saw the example with the prime number calculation. It was much less code. So therefore, it improves maintainability. The less code you have to maintain, the easier it is. It's more concise and less chance of errors. And here's my plug for SQLServerCentral.com. Steve is Steve Jones runs this. He's a great guy, and he keeps on top of all this good material. And there's a good forum out there. In fact, I think Jeff Moden, I think it's the only site that he publishes to, because I haven't seen much of anything else from him other than that. Speaking of Jeff, here's some references to various articles on tally tables. And when you download the slides, these links will be available to you. Any questions? Oh, come on. Either I was really, really great, or I didn't explain things well enough. Okay, let's go.
It's really good. It's just like, I need to digest that.
Yeah.
The only question I have is where can I get the slide?
All right, fair enough. So before I get to that, here's some links also to some free ebooks that are available from Microsoft, Redgate, and SentryOne. They're really cool. And, this is a carryover from when I was doing this at SQL Saturday, but if you want to give feedback, I'd really love that. And you can reach me. Here's my email right here, my website right here, SQLRV.com. There is a tab for presentations, and all my presentations are downloadable on there. So you can reach at SQLRV.com. Anything else? Yes, there is. I had, believe it or not, a lot of people ask me about, well, what does your RV look like? So I put pictures of it up there. All right. Thanks a lot. I really appreciate it.